Evander Da Costa's undergraduate degree was in aeronautical engineering. He's now doing a PhD in artificial intelligence. Evander, what's the role of complexity science in engineering and the physical sciences?
I can give you the example of an application in aerospace. So back in the day when we were designing supersonic aircraft, a lot of aircraft were designed that literally, quite literally, crashed and burned because simply because we didn't have the theory down. But if we had the tools and techniques and technology that we have today that enables complexity science, it would simply be a matter of modeling and simulating the right kind of engineering designs to be able to enable supersonic flight. And a lot of pounds, dollars, and rubles, and of course man-hours would be saved in the process. So that's how I see complexity science affecting.
Okay, so how does it contribute to designing and building aircraft now?
Okay, so imagine you want to design a quieter aircraft, and imagine you have the idea of putting the engines of the aircraft instead of under the wing, over the wing. So that raises questions like, how does that affect the structure of the aircraft? Will the wings reflect the noise adequately so that people underneath it will be able to hear it? What will the vibrations be like? Will that affect passenger comfort? Now, these are questions that can be answered quite easily by modeling the relevant structures and simulating them on a computer, as opposed to spending millions of pounds building and flying the entire setup. So that's how I see complexity science, which is very much a science of modeling and simulating cascading effects.
And what other light does this approach shed?
All right, so if you want to switch to, say, biofuels from the conventional kerosene and petroleum that's used to power engines, and imagine the aircraft you've designed is now really popular and all of the major airlines are using it. And these airlines source their fuels from, say, Brazil as opposed to Saudi Arabia. How does that affect the economies of the relevant countries? And how does that in turn affect the societies in those countries? So this cascading effect of we have an engineering system, and how does that affect the socio-economic side of humanity, if you will?
So what do you think is the significance of complexity science in these engineering activities?
I think there's very much a scope for complexity science going into the future. So for example, the current push for aircraft design to the next generation is for quieter, faster and more fuel efficient aircraft. And to be able to do that, we need to kind of turn up the power of our microscope, dial down deep into the theory of what we already have, kind of be able to model and simulate it to very fine levels and extract all the relevant theories required from that. And complexity science provides the right tools in the right direction, in my opinion, to be able to do that. So I really believe complexity science has potential to affect humanity.
Evander, thank you very much.
Thank you.